Hello everyone, welcome to my channel. I'm Srivatsa MD, studying in Sri Venkateshwara College of Engineering, Bangalore. So in this video, let us discuss about the introduction to Markov chains. A Markov chain is a mathematical system that undergoes transactions from one state to another with the probability of transactioning depending only on the current state. These chains have widespread applications from modeling financial markets and population dynamics to analyzing DNA sequence and speech recognition. One crucial property of Markov chain is the Markov property, which states that the probability of transactioning to the next state depends solely on the current state and not on the sequence of events that preceded it into stochastic process. Understanding Markov chain entails delving into stochastic processes, transition matrix, steady state probability, and observing state. The concept of a Markov chain forms the basic for Markov chain Monte Carlo algorithm, a fundamental tool in computation, statistics, and Bayesian interference. With its elegant simplicity and diverse application, Markov chain play a pivotal role in modern mathematical modeling and analysis. Definition and basic properties of Markov chain. Markov chain are a fundamental concepts in the field of probability theory and stochastic processes. They are named after the Russian mathematician Andrei Markov and are widely used to model random processes that evolve over time and possess the Markov property, which is a memoryless property. The basic property of a Markov chain revolve around the concept of transition probabilities. Each state in the chain has associated transition probabilities to move to other states, and these probabilities are encapsulated in a transition matrix. The properties of irreducibility, periodicity, and ergodicity are essential in understanding the behavior of Markov chain. Additionally, Markov chain can be classified into different types based on their properties, such as discrete time and continuous time Markov chain. Understanding the basic property and characteristics of these chains is crucial in various fields, including physics, biology, economics, and computer science. A Markov chain describes a discrete time stochastic process over a set of states S is equal to S1, S2, and so on till Sn according to a transition probability matrix. P is equal to P of ij. P of ij is equal to probability of moving to state j when at state I. Summation of j P of ij is equal to 1 stochastic matrix. Memorylessness property. The next state of the chain depends only at the current state and not on the past of the process. Higher order MCS are also possible. Transition matrix and state space. What is a transition matrix? A transition matrix, also known as a probability matrix, is a concept used in the field of Markov chain. It represents the probabilities of moving from one state to another in a stochastic process. The rows and columns of the matrix corresponds to the state of the system, and the entries represent the probabilities of transitioning from one state to another in a single step. Understanding state space. The state space of a Markov chain is the state of all possible states that the system can occupy. It is essential for understanding the behavior and evolution of the system over time. The state space can be discrete or continuous depending upon the nature of the system being modeled. In the context of the Markov chain, the state space defines the boundaries within which the system operates and transition occurs. Markov chain examples and application: random walk, page ranking algorithm, stock market prediction. In random walk, in mathematics and physics, random walks are a fundamental application of Markov chain. It models the path of a particle moving in a random fashion where each step depends only on the current position and not on the previous history. Page ranking algorithm: Google PageRank algorithm used for ranking web pages in search engine results release on the principle of Markov chain to determine the importance of relevance of a web page based on its incoming links and the importance of those linking pages. This application revolutionized the way search engine tag and display information. Stock matrix prediction: Markov chain are utilized in finance for predicting stock market movements by modeling the sequence of stock prices as a Markov process. Analytics can make informed prediction about future price movements based on the history data of price change and other market factors. Stationary distribution and limiting behavior. Stationary distribution limiting behavior ergodicity. In the context of Markov chain, the stationary distribution refers to the probability distribution that remains unchanged by the transition of states. Limiting behavior: the limiting behavior of a Markov chain describes its behavior as the number of steps of transition approach infinitely. Ergodicity is a property of making Markov chain that guarantees the existence of a unique stationary distribution and ensures that the chain will eventually visit every state regardless of the initial state. Application of Markov chain: Markov chain make the study of many real world processes much more simple and easy to understand. Using the Markov chain, we can derive some useful results such as stationary distribution and many more. Markov chain Monte Carlo, which gives a solution to the problem that comes from normalization factor, is based on Markov chain. Markov chain are used in information theory, search engines, speech recognition, etc. Markov chain has the huge possibilities, future and importance in the field of data science, and interested readings are required to learn this stuff properly for being a competent person in the field of data science. Markov chain convergence and ergodicity. Convergence: in the context of Markov chain, convergence refers to the behavior of the chain as it progresses through time. Ergodicity. Ergodicity is a fundamental property of Markov chain, indicating that the chain explores its state space thoroughly and returns to certain state with a specific frequency in the long run. Properties of Markov chain: a Markov chain is said to be irreducible if we can go from one state to another in a single or more than one step. A state in Markov chain is said to be periodic if returning to its requires a multiple of some integer larger than 1. The greater common divisor of all the possible return path lengths will be the period of the state. Assumption of Markov chain: the statistical system contains a finite number of states. The states are mutually exclusive and collectively exhaustive. The transition probability from one state to another state is constant over time. Thank you.